TR26, descent initiated, conditions nominal.
Copy, Helderberg. Passing depth 200.
Got a massive structure ahead. Organized motion.
Botneb swarm. Avoid engagement. Watch your bow, TR26. Suspicious lure on the radar.
Seeing a bright light, not falling for that.
Iceberg. Everything just went completely silent down here.
Spikes on the monitor.
We see it too. Massive spikes on our end. That's an APT.
Leviathan is clear. We are at the floor.
Copy that. Deploy the handshake. Excellent. Welcome to Troopers 26.
Good morning. Special moment every year, opening Troopers. Welcome to Heidelberg. For many of you, it's actually welcome back to Heidelberg. So some of you have been here before, some of you have seen many Troopers, some of you are here for the first time. Some of you have seen me opening this many years ago. For some of you, it's the first time you see me opening this. This is, as I said, a special moment. My name is Enno. I'm the founder of Troopers. I'm the founder of EMW, the company running Troopers. This year we have our 25th anniversary, so it's a special year for EMW. We are doing security services, vulnerability research, pen testing, so have been around a long time. Troopers, it's the 17th edition this year. And I'm super happy to see you all here. Thank you for coming. Thank you for trusting us with your time. Thank you for trusting us with your money, actually, which you paid for the conference. And at this point, I'm very happy to state that some of you did not pay a registration fee as we invited them. We revived or we extended the so-called student motivational program. So raise your hand if you're a student who has been invited either by the student motivational program or via Black Hoodie. So that's the future of cybersecurity. We are glad you're part of the crowd. I tried to find some non-copyright pictures of John Connor or Sarah Connor, but I couldn't manage. So you get the idea why this is important that students join Troopers. And there is not only one EMW company, the one that has 25 years this year. There's a second one, your trusted partner for incident response. So we are the folks running Troopers, and Troopers, from our perspective, obviously that's biased, Troopers is a special event. And we usually state Troopers is around three main topics, which we call content, collaboration, and community. Content, that's our part. We try every year to come up with a nice agenda with some cool talks. Up to you to judge tomorrow evening if we managed to deliver that. So we are in charge of the content, and totally fair if you have high expectation there. Totally fair if you have high expectations for the speakers. No pressure for those of you who are speakers. In any case, that's the element where we, the whole Troopers Orga team, and trust me, everybody at EMW put a lot of energy, effort, long nights into preparing this. So bear with us if something doesn't go perfectly. Trust us, we did our best, and I'll get back to this in a second. In any case, content, that's us in charge. And let me take the opportunity to come up with some organizational, some logistic notes. 3 things happen tonight. The shared dinner at 7 p.m., the so-called storytellers, which is organized by my colleague or moderated by my colleague Saif, who is here in the room. Say hi to Saif. He's find this face if you want to share an interesting story over a fireside chat in the evening. Many people loved this in the last years. This is the guy taking care of this. Besides that, well, there's a Capture the Flag, organized by the nice team of NFITs, who have also been here last year already. Same folks running the CTF. Many have played last year, so feel free to register, and you'll find the information how to do that either at the info desk or in the material. Content is only one thing. There's 2 more things which I mentioned. That is community and collaboration. Troopers is very much about learning, and learning not only, say, from the people on stage who are among the best in their domains, but also learning from each other, talking to each other, exchanging, and that's what makes Troopers so special. So please be your best collaborative self this week, or over the next 2 days at least. That's what makes Troopers unique, and we really want that people leave either tomorrow evening or on Friday totally delighted, but not like Troopers is an amusement park, but in the sense of, oh, I had this good conversation, I got this cool research idea, or hey, this person I talked to, I really learned something from that. So that's what Troopers is about. Make this happen, and this is all of us, all of you here in the room. There are some more things which make Troopers special. The badge. We'll talk about the technical features of the badge in a second. And I already mentioned some things recurring at Troopers. There are some things new every year. Cybersecurity is changing. Cybersecurity is changing faster than ever, according to certain sources. The badge has seen some changes, but there is also things that happen not every year, but several times. There is some drama around the badge. Some of you might recall this slide from last year's opening. As 2 years ago, we had a situation, the badge didn't go through customs on time. It was stuck at the channel between UK and France. So somebody had to drive to, I think, Dunkirk or Calais to pick up the stuff and to bring it in Heidelberg so the badge could be assembled or at least distributed at time on the first day. So last year we were like, oh, this year we solved this. And this year we solved it too for the badge. But the badge has a battery. And this thing happened. The battery was stuck in customs since 2 weeks. Didn't really move forward. We tried to push and we tried to call people. And on Monday evening, they were like, okay, it's cleared now. And then on Monday they told us, the batteries will go out today, you will have them tomorrow, which would have been yesterday. That's, well, ambitious, but at least it should have worked. And the badge team, those are incredible folks and putting really efforts into this. But then, turned out yesterday at noon, nothing had happened. So we decided, okay, we have to do something. We have to move. And luckily, one person, a friend of us on the site where ENW is sitting, he was around and he jumped in and said, okay, I'll drive there. And you might have spotted it's in Leipzig, 300 miles for the US folks from Heidelberg. So 4.5 hour, up to 5 hour drive. The person set off and well, karma kicked in, or whoever, Murphy kicked in. The person, say, 100 kilometers from Heidelberg, a screw on the road was at the wrong place, which meant leaving the Autobahn, getting some service, and these folks could remove the screw, but they could not change the tire. And they were like, okay, you can continue, but only driving 80 kilometers per hour, which, do the math, might not have worked for picking up the badge. And what happened next maybe can be seen in this video. So tires were changed. The drive could continue. So far, so good. And our friend advanced towards Turing, towards then passing Turing to get to Leipzig. But in parallel, there was some email exchange with customs in Leipzig, which went like this. They were like, okay, some teams talking to each other, where is the stuff? Maybe it's in some place, presumably, that was the response. But at some point in that exchange, and you might spot it's 4 p.m. already yesterday, at some point this turned up in the email exchange. Only tomorrow morning, 1 hour before Troopers opens, at, well, pickup would be possible. We were like, oh, no, wait a second, folks. This is not how this works. So people jumped on the phone. We were like, hey, you told us we could pick it up. We could pick it up today, that you have long working hours. In the end of the day, luckily, 7:30 p.m., the packages were recovered, were opened to check is the real stuff in it. Like in a movie. Usually in the movies, there's other stuff in there when you open a package delivered from a warehouse. But yeah, the badge and the batteries for the badge are here. And we'll explain in a second what you can do with it. Well, dear.
Yeah, hello. Yeah, welcome to Troopers this year. Great to see you here. Yeah, this year the badge went some major redesign, I think, as you may have noticed already. We have several interesting features like a Game Boy ROM, and of course an AI assistant, which is backed by a self-hosted model, which can also be asked maybe for a flag. And also, yeah, we have a notification system where we can ping you if something important happens. And yeah, also some nice functionality we had already last year with the last MCU, which is basically the same, which Jan will briefly talk about.
Yeah, so hardware-wise, it's basically the same design as last year. So we wanted to do like a reusable design where we can reuse parts of the electronics for next year. We stick with this idea also for this year. I'm not currently sure how we will handle it, but we will probably at some point make somewhere a box where you can return your old MCU board so we can use them for next year. And yeah, there was one feature that we have already implemented in hardware last year, that is NFC. And there were like a couple of people trying to get this running because it's a quite complex protocol architecture, but this year, thanks to Claude, it's working. So, yeah.
Thank you.
And one last thing, maybe you noticed that the agenda on the badge does not work. With the new auto update .8, it should work. Also, for some of you, there's the storage broken, some images are missing. We're currently investigating why, and we hopefully can just reflash them, and then it will work. So if you have like a storage problem and no icons are showing up, just go to the desk at the entrance. Thank you.
One more thing where the badge could play a role.
Oh, sure, yeah. If you found the URL changed a bit, so this year it's con.troopers.dev instead of DE. There you can like find all the challenges you can do here and also enter the tokens. And this year also you don't need your like 4-digit 4 hex characters for entering it. Instead you use your secret ID, which is accessible with the ID app, and then you press select.
Thank you, Matthias. If you ask, okay, what's this thing about the challenges? Well, part of that is to find out, if you're here for the first time. Certain codes play a role. Experienced people in the room might know where this might be of interest. I saw, I would say, at least 50 people raising their cameras. For 49 of you, I'm sorry, this is a one-time token. In any case, I'm super happy you're here. I hope you will enjoy Troopers. You will have fun. You will learn something. And with that, one last thing which I forgot. Actually, two. You see, I'm as nervous as all the speakers who speak at Troopers. The run. I spoke about the evening events. This one is happening tomorrow morning. We did some change there. Okay, just kidding. It's still 10K. It's even a bit less since we changed the route. It's in the morning, it's along the river, so it shouldn't be too hot. I think 92 people during the registration clicked, I'll do the run. That would be a record. And you may know that for every participant in the run, for every kilometer actually passed, and there we calculate with the 10, €5 go to the charity. Troopers has a charity program which it goes to two organizations, Plan International, and we added a new one, Medea, where a young student from Southern Africa will be sponsored to pursue their cybersecurity studies. 3 main sources for the charity. One is the run, one is at the rec desk. You can get Troopers rec from previous years for a donation. And there is some other sources. Of course, you can just give a donation. And some speakers and workshop trainers refrained from their honorarium or for travel reimbursement. I'll give the names tomorrow. Thank you. Thank you, everybody, in advance for contributing here. That's the run tomorrow. On Friday, there is roundtables. And this is, you might have noted, I'm like 10 minutes in this thing, or maybe 15. First time I come up with the term AI. Obviously, it's the elephant in the room. Lots of talks on AI. Some of you have joined workshops on AI security over the past 2 days. One roundtable will cover AI from an offense and defense perspective. 2 new roundtables, things have changed. One is on supply chain, and one is on identity. All those happening Friday morning. That's my part for the logistics. Again, welcome to Troopers. And it's my great pleasure to announce this year's keynote, which will be given by Marion Masalek, who has been at Troopers many times before. Some of you may know her from different roles, from different activities. I'm super happy, Marion, that you join us this year for the keynote. A special round of applause for Marion. here, Troopers is officially started. Okay, den brauchst du. Mich können wir ausmachen, glaube ich. Danke.
All right. Good morning. Hello, troopers. I'm extremely excited to be back, and I'm telling you, extremely excited. Most of you might have never seen me before. I've been here for the first time in 2014. That was over 10 years ago, and that is when I realized how old I am getting. I've been in this industry for about 15 years, and I've held so many different jobs, and today I will be talking about all of them. The topic of the keynote is Ship It, They Said. Security research and product development at scale. First of all, who am I really? My name is Marian Marszalek. I spent approximately half of my career in security research, looking at things, taking things apart, writing blog posts, writing papers, writing proof of concepts, publishing everything on GitHub, and leaving it sitting there. That was my security research life. And from that researcher existence, eventually, I went into the big corporate world. I worked for corporate America for almost 9 years. And something that hit me preparing for this keynote was that my first job, I like to call it my first real job, which isn't exactly how that works, but it was the first job at a big, big company. I met the person who introduced me to that opportunity here at Troopers. And some of you might have met him. His name is Rodrigo Branco. Rodrigo ended up being my manager at Intel for 3.5 years. And yeah, I'll bring up some examples of that adventure today. Anyway, the other thing you see in that slide is I am about to start my PhD journey. I quit corporate America last year, and I'll be starting in academia. And again, the person who looped me into that adventure, his name is Sergey Bradis. He's the professor who I'll be working with at Dartmouth College this fall, and I also met Sergey for the first time here at Troopers. So I have a very personal connection to this conference. And that, again, makes me super happy to be here today and have the honor of delivering this keynote. To start us off, the arc. As I just mentioned, my arc was from security research, and then I went into product development. And that was a journey that I didn't exactly expect to work out the way it did. Because as a security researcher back in the day, again, I was used to looking at one problem at a time, diving really deep into that problem, enjoying the rabbit hole. And that was a very rewarding process. And through that research, I never even thought about what the world impact would be. Because of course, if we do security research, we expect our research to have impact, correct? Like we publish our insights, we publish our code. And we hope that somebody picks it up and takes it to the next level. Like, if I'm the one blazing the way, then somebody else will, right? They will take those results and integrate them in the bigger picture. Except for most of the research we publish, that doesn't actually happen. Anyway, fast forward, I joined Intel. After Intel, I went to AWS, which is still the biggest cloud provider that we have these days. And I was confronted with how the real world sees security research. And that was rather sobering. In both of these big companies and these environments that I worked in, the proof of concept was not the goal, right? If you work on large products, large deployments, The proof of concept is the first step. That is the first idea. That is where the curiosity leads you. And that is where the reward kicks in. But in terms of taking that proof of concept to an actually deployed product, we're talking about maybe a month of research, and then probably about a year to a year and a half of deployment. And that is rather frustrating for a researcher. But let me start this talk with the actual research. Research is fun, right? Research is rewarding. We deliver the proof of concept, and that feels good. That is why most of us work in research. And yeah, that's what we'll be starting with. Research versus applied security. Something I haven't mentioned yet, this talk is structured in 3 chapters. The first one is focusing on the research. Here's the obligatory hacker stock photo. The second chapter deals with the security engineering and the scale that we would meet if we were to actually try and manifest our research idea in a product. And then finally, the third chapter is about how AI will change that process, because of course, today you can't give a talk without actually talking about AI as well. And I'll close it off with a note about community. Why do we do research? And I've already mentioned that it feels good. Why does it feel good? There's something to say about brain chemistry that makes us happy. There's a lot to say about what that brain chemistry exactly is, but then there's one thing that I believe is the biggest driver behind security research, and that is dopamine. Dopamine is the neurotransmitter that hits you if the exploit chain worked out, if you have figured out what the malware does, if your proof of concept tool runs. At that point in time, you haven't changed the world yet, but that is the big idea behind why security research feels so good, right? We have shown it can work, so obviously it will work forever on in the future. And yeah, let's call that the biggest driver. And actually, if we go looking for how that could work in the real world, you will find that there's very few examples where a researcher or a line of research has actually changed an industry in any way comparable to how one person turned boot security upside down like nobody else before. Some of you will have heard of Alex Matrosov. Alex Matrosov is incredibly impressive. Somebody I look up to in how he conducts his research and his work. But like, the reason why isn't because he showed one vulnerability or one exploit, or even just a number of exploits or a number of vulnerabilities. Alex Matrosov almost single-handedly turned hardware security upside down. He revolutionized how the industry sees UEFI and boot security today. If you look at the research that Alex has published over the years, like I say, Alex and consorts, right? There was a lot of people involved in that field, but specifically around the publications that Alex has done, you see the continuous impact that those research publications have had on the industry, mostly also because Alex eventually went on to found a company named Binarly, which literally has the purpose of revolutionizing how vendors, hardware vendors, see security of their products. And that, I think, is the best example, if we look at security research, of how security research can change this industry. They have a counter on their website which shows how many disclosures they have made since their founding. And the numbers show that with their 205 disclosures impacting 511 products, that effectively they have had contact, that they have been in touch with most of the hardware vendors that we see of end-user products these days. Like, if it says 18 vendors, there isn't so many more than 18 vendors in the OEM space altogether. And that is just really impressive when we talk about real-world impact of research. And here's another piece of security research that I found that I think is peculiar, concerning, and incredibly interesting. Last week, I was at a conference in Montreal, and at one point during the conference, I was sitting at the hotel bar, as you do at a security conference, and found myself sitting next to a researcher named Joe Grant. How many people in the room have heard of Joe Grant? That is not enough hands. Joe Grant is a legend. He was one of the hackers who was part of the Love Heavy Industries hacker group in the United States back in the 90s. And ever since has built his hardware hacking skills to be one of the most prolific hardware hackers in this industry. And anyhow, I was sitting next to him, and we're talking about a presentation he's given recently at hardware.io, where he was talking about a hardware espionage implant that he happened to find in a crypto wallet device that he ordered off of the internet. And my ears got really big when I heard that. I was like, you're saying you ordered a random device from the internet and you found malware? And so we got to talk about that. There was an actual hardware implant in this device, like somebody added an extra chip, and that chip was running a piece of software. The purpose of that was to steal the recovery seed from that crypto wallet, which, of course, as you would do if you build implants for crypto wallet devices. And so far, so good. He shared that binary with me, and I'm a reverse engineer. I will look at that binary, because that's what I do. And the reason why I'm so excited about this is, wrong button. The reason why I'm so excited about this is because I am really interested in malware. That is my business, and that is my biggest interest these days. And specifically, I'm curious about malware that runs in spaces where nobody goes looking. And there is a lot of those. If you look around you, there's so many devices, and all of those can run software. And none of those actually run anything comparable to an EDR or an antivirus or a monitoring solution that looks for malicious behavior. And yeah, the Ledger Nano X is just one of those examples where software was running. And it just so happened that one person went looking, but can you think about all the other devices that we operate these days where nobody ever looks under the hood? And as it turns out, I'm not the only one who's worried about that. There is a company named Grey Noise. They published a report that's called the State of the Edge report, which I find rather endearing. And they were talking about they're specifically focusing on threat detection in the IoT market, among other things. And they had this really interesting report. I'm like, let me help you read what I've underlined there. They were specifically looking for how that space, like the edge device security space, is changing. Back in the day, it was IoT security, and now we're looking at whichever device lives on the edge of a network, which isn't exactly the same thing, but close enough. And they were noticing that there's a lot of movement. They were noticing that botnets changed size at an extremely rapid pace. They were monitoring one botnet that grew from 2,000 instances to 300,000 instances in approximately 2.5 months. That is crazy. Why can they do this, though? Because IoT security and edge device security is just not at a level where anybody would stop them, and that is scary. They also outlined, however, that a majority of infections that they saw happening through ND exploitation were using one single vulnerability that was reported and fixed in 1999. That was 26 years ago. That vulnerability is older than some of us. And that gets me back to the point, this space is moving really rapidly, and nobody's looking. A lot of research happens around vulnerability discovery and exploit development, and then there's a lot of work going into patching and distributing patches and making sure that the fleet is okay, and so on and so forth. And then we have 26-year-old vulnerabilities that are happily exploited in this space and help malware spread from one device to another device to another device to another device until we have botnets that are 300,000 devices big, and nobody goes looking. That is what keeps me up at night and gives me goosebumps. And The next slide might make some of you rather unhappy, but I had to add it here. Like, what is being done about the security of those devices? Patching would be nice. That's not, I can't see patching of these devices is not happening, but it's not happening well enough and fast enough and like a large enough coverage. So the European Commission set out to build legislation around it, because legislation these days is how we solve security problems. Not. But this is interesting, because legislation itself, you would think that that is the world impact that we would like to have with research, right? We published a report about the vulnerability and about how bad it is and about how it could help malware spread automatically between devices. And then somebody picks up that understanding of how bad this looks and does something about it. Whether that is legislation or better patching procedures, I'll leave that out front. But we do have people working on legislation. Think about that, what you will. Actually, if you look at this one specific legislation in detail, some of you might break a sweat looking at these numbers. Maybe I certainly would if I were working at a device vendor these days, because this piece of legislation actually starts kicking in this September, specifically on the 11th of September this year, and it requires that vendors of devices report vulnerabilities and severe incidents at a light-speed pace. The European Commission expects these vendors to report within 24 hours if their devices have been under attack. If you've ever been at a large-scale incident at a vendor, you know that the first 24 hours, nobody thinks about filling out a form for the European Commission. That will change rapidly this fall, and my condolences to anybody who's working these tight timelines. But like, the reason why I brought this topic up here is not necessarily because I'm a big fan of cybersecurity legislation, but to point out one thing is that you saw at the State of the Edge report how bad that's looking like, and now we have a tool that supposedly fixes that, but we don't have this tool because security research made the European Commission worry about IoT security, right? We had a lot of research going into IoT security over the years, and none of that has caused legislation to roll back faster. It was really just that the space itself was so broken that the European Commission started wondering about it. And that gives us to think, like, wouldn't we rather the research we did would have had this type of impact? Now, a bit of a change to lead over to product development and deployment. Back when I was at Intel, I wasn't looking at IoT security at all. I was asked to work on mitigations, which in itself is a funny story. Imagine one day I'm sitting in the lab and Rodrigo, my team lead, comes in and says, you work on compilers now. And I was like, what? And that was the start of a beautiful journey of me looking into mitigation, prototyping within GCC. GCC at the time was the compiler to build the Linux kernel, and in order to deploy mitigations, like compiler-based mitigations to the Linux kernel, you need to understand GCC. And that was my job for about a year and a half, which is not a lot of time to look at compilers, one might say also. Anywho, I cannot speak in detail about what exactly I did then, but I can talk about the one thing that is very public and very curious to look at, which is the mitigation for a vulnerability called Spectre v2. This slide is the shortest technical summary you will ever get for Spectre v2. Enjoy. We have three items that need to play together for Spectre v2 to be exploited. One of them is indirect branch prediction, one of them is speculative execution, and the third one is cache timing side channels. Indirect branch prediction is the component we're poisoning so that speculative execution is redirected from where it would originally be speculating to a different spot where it speculates over a read primitive, and that read primitive supposedly then is reading secrets. Those secrets through that procedure would manifest in the system's cache, and then a cache side channel attack could grab those secrets out of the cache, which we extracted from protected execution environments such as the Linux kernel. So far, so good. That was the summary. Then, if you think about how to mitigate that, mitigations are tricky. I'll be talking about this in 2 slides from here, where we have the attack, which might take days, weeks, or months to take to fruition until we have that proof of concept. And then the mitigation, which might take weeks, months, or years to be implemented, tested, deployed, redeployed, improved, etc., until the mitigation actually has impact in this industry. And if you look at Spectre v2 specifically, there is one mitigation which is the most fascinating one to look at, if I may say so, because it is rather small, it is rather simple, and it is rather easy to implement and fast to deploy, and that's called RedPull-in. RedPull-in was published almost alongside with the description of this vulnerability. And I say simple. RedPull-in is relatively simple if you spend a lot of time inside of GCC, which most people haven't. RedPull-in is a compiler-based mitigation. That means that the compiler itself goes looking for those indirect branches that are the root of the problem and goes patching those indirect branches with a mechanism that stalls speculation for the execution of those indirect branches. If you see at that slide, the one thing that I wanted to call out is the loop that's right there. It says speculative path, and then speculation runs in a circle. That is literally how you can imagine this mitigation. We take speculation and we send it on a looping adventure where it never actually delivers any results. That means that those secrets that we were wanting to read out of memory don't actually manifest in the cache. So no attacker can steal them, which is great. That means that Spectre v2 is mitigated, mostly. The problem with that is that security research was really excited about this. We have this really lightweight mitigation which goes into the compiler, and then we just rebuild the kernel and we're all secure. The guys at Intel who deal with CPU performance and performance measurements and with the marketing portion of that, of how Intel hardware is the fastest chips on the planet, right? They were not excited. Because for Intel processor performance, this mitigation meant a hit between 1% and 20%, depending on the architecture and the compute load you were running. And if you tell one of those guys at Intel that their chip is now 20% slower by default, they, breaking a sweat is an understatement. They're not happy with you, right? And so that mitigation was broken from the start. And as I broken, the security requirements for it were met, right? Speculative execution didn't happen anymore on those branches that were so vulnerable. But the mitigation itself was definitely not what the industry wanted or needed. So improvements had to happen. And that is the rabbit hole that I was trying to point out. We had the attack, and we had the mitigation really quick, and we deployed that mitigation, and then the real work started. And that real work is what had me so much about my adventure in this industry at Intel and later at Amazon. Because to sum this up real quick, we have the security research which shows the vulnerability. Mind you, shows a class of vulnerability. That's the pinnacle of your research career, right? Finding a new class of vulnerability. Which is the easy part. And lots of you will look at me with big eyes, because writing that exploit chain was definitely not the easy part. But if you compare that to the process it takes to fix that bug, and then to come up with the mitigation to mitigate that class of vulnerabilities, oh boy, do I have stories. What is on the other side of that process? Well, to sum it up, simple, we have product ideas or mitigation ideas. In that sense, we have a design. We figure out how to build the thing. Of course, we have reviews, because that is part of the process, and then we improve the design, and then we implement the thing. And if you imagine that with RedPull-in, that was all done within weeks, right? Because there wasn't really time to go through these processes and procedures that are there to plan an actual product or an actual mitigation raid. But that's approximately how all these processes go, and then we test and we roll out. And then there's 2 points that I could not stress enough as the cause for a lot of migraines at large corporations, which are operations and support. Because that is one thing that it gets me back to like the publishing of proof of concepts on GitHub. These projects are now actually maintained, right? How many times have you downloaded a tool from GitHub and tried to run it and it didn't compile, or it ran and it didn't produce the results, or it produced results but they were outdated or wrong? And, I recently have, like last week, I downloaded an IDAPRO plugin, and it doesn't build anymore because the IDAPRO API has changed. And of course it has, because the plugin was written 3 years ago. And then I said I had to like try to fix that API, and it took me a day, and then the thing ran, and then the data that I got out of IDAPRO wasn't actually what I expected, and then I gave up. That's kind of how that goes. And you can't do that if you build a mitigation that needs to be shipped industry-wide, or a product that needs to be running on thousands of computers or millions of instances, et cetera, et cetera. You need to be on top of what's changing throughout the whole stack of dependencies that you're using. And if anything in there changes that derails your solution, you go update that solution. And then there's something called backwards compatibility, which is also a big source of migraines. And that is only one thing in this big mountain of stuff that we need to think about when we build these systems. Because there's this basic principle of what worked on my machine doesn't work on your machine. That is something that I've seen again and again. And you wouldn't believe how many meetings I've been sitting in where I explained these very basic concepts to people, whether they believe them or not. We talked about that a detection idea. Let's talk about threat detection. Like we have this beautiful idea of how to detect a certain strain of malware is not actually the same as a detection product. Like taking that idea to the implementation of the service that is supposed to do the job is a long line of work where, again, the proof of concept is the easy part that you start with, and then the implementation, the triage, and the fixing of corner cases is the actual road to success. And that is why this takes months and months or years at a time. And then there's another point that I would like to stress where it says a proof of concept is not a weaponized exploit. I'm not in the business of writing exploits, but I seem to be hanging out with those people a lot. And last year, I found myself at another conference having this conversation about how exploit development has their own style of operations, which was new to me, to be honest. Like, imagine you have this proof of concept, you write this chain of exploit, and then like you own the system, you have your shell, and that's great. What if that exploit is supposed to run for months and months or years at a time? Like the longer your ODA lives, and you can exploit it, right? The more money there is to be made with it. That's kind of the thought behind it. And that requires operations, because that exploit at that point in time is nothing other than a product that's deployed in the wild that's depending on the software stack underneath. So say your bug has still not been fixed, and theoretically that's still exploitable, but something in that chain of command of that exploit is changing, like one of those libraries is being updated and address offsets shift. Somebody has to go and update that code so that your quote-unquote product still works. So not even those people can escape this long march of implementation, testing, and support and operations. What did that mean for me on my journey, however? After Intel, I joined AWS as a job in threat detection. I was working with AWS GuardDD on detecting threats on Linux platforms in the runtime and statically on disk. And coming from antivirus, like my idea of threat detection was always that we look at the threat and then we build a signature or a detection and like we ship that detection and that's it, right? That in fact is how most of threat detection works if you look at the classical model of antivirus. But then again, I was at a cloud provider, and cloud providers have a set of problems that is almost entirely different than most of what the rest of the industry is working on. Where the cloud provider, of course, like building the proof of concept and like implementing the detection idea was part of the journey, but it was only a short step on that road. What those companies are more interested in is how reliable is this detector? Is there any risk that this detector is going to take down other services? Like, what's the blast radius if this detector fails? How fast is this detector? Can we run this on the load of data that we're processing every day? How big is the throughput? How big is that detector? Like, if we have 50,000 of those detectors running somewhere, how much space do we take up? How much time do we take up? Et cetera, et cetera. There's a lot of thought processes that go into building the actual product behind that. And those don't usually make great papers at Usenix, which is why the industry doesn't talk much about these issues at all. And this is what gets me to security engineering, development, and operations. This is what I did for the most part of the last 4 years at Amazon. What it means to work at scale. People have written books about this, and I won't go into the actual details. There is a great handbook that's been published by Google. It's called Site Reliability Engineering. And if I remember that title right, there is another document that was published by AWS that's called the Well-Architected Framework. I can recommend those reading sources if you're interested in going into the details. But for today, let's keep it high level. There's something called the false positive economics rate, which is, again, when we're looking at when we build large systems, the numbers don't work out the same way they do in a lab environment. If you have a rate of 1 billion events that you're processing per day, and you might think that 1 billion is a big number. If you think about all the log lines that are captured in AWS on a daily basis, 1 billion is nothing, right? But let's take those billions just for the sake of this example. If we have a false positive rate of 0.01%, that means 100,000 false positives per day. That is a lot of SOC hours. Security operations will be sitting there triaging these false positives all day long. That is a lot of money that goes into just responding to this load of noise. And this is how these large systems think. Like 0.01% is just not good enough. And if you look at papers that have been published in the threat detection space, 0.01% is great, right? If you have 1% false positives, they're like, we're winning, and the paper gets published. And AWS is sitting there and goes like, no, no, not good. Because if you work at scale, what you're looking at is everything under the sun. The more customers you're serving, the more likely you find those customers with the weird configurations, with the odd workflows that look like they're malicious, but they're not. They're like borderline legitimate. You look at a lot of legacy integration, like a lot of systems that are outdated or maybe even end of life, that look like the odd outliers in your data set. And every anomaly detection in the world would say that this is the weird things that we need to bubble up and report to the security team. But in reality, they're really just corner cases. And that brings me back to something I mentioned earlier. If you build these large-scale systems, your job is not the proof of concept. It's not showing that the thing works. It's making sure that it doesn't take out anything else. And that's the hard part. This is the long road ahead. Because scale can get back at you. Again, in research, the corner cases are the footnotes, right? The paper mentions that these things could happen. And then in production, the corner cases are what is our job. But if the scale gets back at you, being prepared for these cases is just really, really hard. There's a lot to say about the miscalculations that this industry has done. Both when we deploy large-scale threat detection or industry-wide mitigations, there's this assumption that attackers will do a specific thing and will not do the other thing, right? When I was working at Amazon, we had a poster on the wall that said, the attacker didn't stick to the rules we made up. And we were the ones building the detection rules for our agents. Anyway, just a joke on the side. There's one point on the slide that I wanted to particularly stress, which is drift. Which, even if we have a great proof of concept, and even if we build that proof of concept into a reliable product, and we ship that product, and it is out there, and we have our operations and support in place, and we have monitoring and all the visibility we want, nothing promises us that this solution will still work tomorrow. Because in this concept of drift, the both the adversarial load, like the way attackers behave, and the environment that we operate in itself can change. And environmental drift is probably the hardest thing to deal with in these deployments. That brings you back to, like, if one of the libraries in our deployment stack is changing, we need to be, first of all, we need to be aware that that's happening, and second, we need to be able to react to that in time before the deployment out in the wild is failing. And that is just a very short summary of what happens when scale gets back at you. There's a lot more to say about that, which we're not going into today. But this leads me back, this leads me on to the next point that I wanted to stress, which is operations. And I've talked about operations a lot. What is operations? Operations means keeping the lights on, making sure that the deployed product is still running, that every customer still has the same experience, that the data that goes in is still the same quality that went in yesterday, and the data that comes out is still the same quality that came out yesterday. And like specifically, if you compare operations to security operations or operating security products, you're living in an entirely different world, because suddenly you're not even just dealing with the stack underneath your deployment changing, you're also dealing with adversaries who are trying to make use of that problem. And this gets me to another example that I've prepared that will showcase what I mean with that. How many people in the room have heard of channel file 291? A few hands go up. You will soon know what that is. Channel file 291 was responsible for this. Blue screens at an airport. Blue screens all over New York Times Square. Blue screens on card reader stations. Blue screens in offices. Blue screens at, I think that's another airport. And blue screens on the street with billboard signs. And there's so many more pictures. Channel file 291 was detection logic deployed by CrowdStrike to their Falcon product, which was also the reason for the big CrowdStrike outage in 2025. Everybody will have heard of that. And the people who knew the number of the channel file that caused the crash probably read the postmortem. And I'll get the postmortems in a second. This was probably the biggest recent outage in modern day computing we have ever observed. For a lot of us, this was like watching a movie of how the blue screen pictures came up on the internet and services went down and came back up. And some of us might have even been stuck at the train station at the time or at an airport. I was lucky enough to be at home and not having to go anywhere, but at the time when this happened, I was an engineer at AWS, and I'm telling you, what I did that day, all day long, was looking at our pipelines. For no particular reason, right? Like CrowdStrike is not running in the AWS deployment process. But we were deploying a lot of software at the time, 2 million of customers. And we were looking at that CrowdStrike outage, and imagine the first 24 hours, nobody really knew why things were crashing, but they were crashing. And we were just sitting in our lab, breathing heavily, looking at our deployments and seeing that nothing was crashing on our end, and deployments were still going through, and the customers were still up and running. And that was very stressful. I can't imagine how stressful that was for CrowdStrike. The channel file 291, as mentioned, was detection logic, as we found out later when the root cause was actually published. So what caused this outage wasn't the push of code or a change in logic necessarily. The root cause was a latent bug that was in the platform a long time before channel file 291 was published. It just so happened that this channel file caused a corner case, which then triggered the bug, which then caused all these Windows machines running CrowdStrike Falcon to crash. And some of them without the possibility to bring them back up quickly. And that gets me to something very specific. I'm not going to be talking about CrowdStrike whatsoever, because a bug like this lives probably in a lot of platforms that are deployed today. We're talking about the corner cases. Again, this is not how the product is supposed to work, but that was this one little sliver, a parameter in that channel file, which wasn't there in prior channel files, and then it was, and then the parser couldn't deal with that, and then the crash happened. These bugs happen all the time. What was special about the CrowdStrike incident was the massive blast radius that this one had. It was how quickly this triggering file was deployed and how bad it was for the machines that were affected. And that gets me to another point. The product that CrowdStrike is running itself was a security product, right? A threat detection product. Threat detection products themselves are attack surfaces. They have privileged access. As it was with CrowdStrike, that driver was living in the kernel and was able to tear down Windows altogether. They run on every host. That is the whole point of security products. They're deployed everywhere. As far as you can deploy that product, you will. And then the third point, their time to update is instant. And that, there I'm not talking about code deployments, right? We're not talking about an update to the driver. We're talking about the detection logic. Detection logic in modern threat detection products needs to go out as fast as it can. Imagine you have like a new piece of malware, like a new threat emerging, and the company does their best, like in a hurry, to define that threat and then ship that definition to customers so that everybody's protected. So far so good. That also means that they're working in a hurry, and deploying things in a hurry is not a good idea. And then there's this list of reasons why these processes fail. I just told you that these type of bugs, they exist in lots of services that are distributed today. There's something to be said about blast radius. Like, that is a point in the design process of your product where you want to be thinking about not whether the thing goes wrong, but like if the thing goes wrong, what is impacted. And that's when we're talking about blast radiuses and how to limit those blast radiuses, and then we have guardrails in place, et cetera, and whatnot. And that's apparently something that hasn't happened with general file 291. Anyway, something that CrowdStrike noticed in their postmortem, which, by the way, is a really interesting postmortem to read, if you're into that, is that their validation validated the wrong thing. It's not like there were no guardrails. It's not like there was no checking and no reviews. It's that they were validating a thing that didn't capture that corner case that eventually caused the crashes. The underlying bug is what we call a latent bug, because it's not like they shipped the update and then the bug was there and then the bug crashed. But like the code update that was behind that crash was shipped weeks, if not months, before the actual channel file tore down those drivers. And then there's something else that I wanted to point out in this section here that will become important again in the third chapter when we talk about AI, is that these systems are complex, right? We're not talking about a product that runs on a machine, but there's dependencies, sometimes hundreds of those. And if you look at the cloud, there isn't like a service, if you would look at it, like a sliver like that. But these services running in your cloud environment, they're all interconnected. They're microservices, and they're all talking to each other and have dependencies on each other. And as such, like, we're building extremely complex systems. And then one major issue that not only security operations, security products have, but I think most development environments that we have today, is that oftentimes there is something called tribal knowledge. Like, there will be one person in that organization that knows exactly how this one piece works, and then there's another person that knows exactly how this other piece works. And if you have an incident that captures both, you need both of these people in the room. And that is a major issue, if you think about that, because it can't be automated away. You can't replace tribal knowledge with an AI bot, at least not yet. And yeah, we have all these different points that work together for these processes to fail, and need to work against that. Anyhow, what happens if things go sideways, and they do quite often? Then we do something called a postmortem. And I've been throwing that term out rather freely. Postmortems mean that we look at the problem that occurred and figure out the root cause, and then we talk about preventing that issue in the future. The point of postmortems is to learn. It doesn't help to find the person who's responsible or the team who's responsible and go on punishing them. The better idea is to talk to those people and have them do the analysis of what happened and then present it to the rest of the group so that everybody can learn from that mistake. And then one of my principles at Amazon used to say a lot is that a post-mortem you don't act on as just a story, right? We're not there to document these outages. We're not there to make sure that everybody heard about what happened. We're there to make sure that the future turns out better than the past. And one company that's actually really good about postmortems and the whole postmortem process is Cloudflare. Cloudflare is an infrastructure company that lives on the in-between layer between the user and the web services they're using, and that makes them very important because they work through large swaths of the internet. And if Cloudflare goes down, a lot of the internet goes down. That is why these people have learned how to do postmortems properly. They have a blog that deals with nothing but postmortems, where they explain all their outages, why they happen, and how they're fixing the problem. And they had one project which finished rather recently in May 2026, which is called Code Orange, Fail Small. Again, if you're a product deployed to millions of customers, like failing for all of those millions of customers is bad. So if you have to fail, and you will fail, because everybody fails at some point, you want to make sure to keep that blast radius rather small. And the reason why Cloudflare came up with Project Orange started on November 18, 2025, when Cloudflare deployed a change which caused a large outage for their services. There is a blog post out there which describes all of what happened, and they use the words that Cloudflare took down large swaths of the internet. And if you look at the websites and the services that were down that day, it is impressive. It is a lot of them. And those included Twitter and Discord and OpenAI, DigitalOcean, 1Password, and so many more. It's because, again, Cloudflare provides a lot of infrastructure that provides access to these services. The root issue was a permission change, which takes us to an entirely different realm of this topic, right? We're not deploying code, we're not deploying data. It's a configuration change, which triggered a latent bug in how Cloudflare's proxy server parses data files. That permission change meant that a SQL query suddenly delivered content that was twice as big as it used to, and that caused content files to be twice as big as they were supposed to. And there was a hard-coded size limit somewhere in the proxy server's parser. And that caused an error. But the actually interesting part about this postmortem is that the error that happened was actually handled. It's just the way it was handled still led to a crash, because the corner case that happened wasn't manifested in that error handling procedure. And that is, it's frustrating, right? They did almost everything right, and then this one corner case that was missed again took the internet down. Something else that was interesting about the postmortem is on the screen here, the graphic I'm standing in front of, where you see spikes. That is the request volume that Cloudflare was still seeing from their proxy server fleet. And if you look at those spikes, people were confused when they were responding to this problem, because it wasn't a clear outage from the start. And I could suspect to large systems and how they're being deployed. Cloudflare at the time was thinking that they're under attack by a DDoS botnet because the traffic wasn't continuously going down or like disappearing, but it went down and came back, and then it went down and came back, and it went down and came back. What they didn't realize at the time was that these spikes happened not because a DDoS botnet was shooting traffic at their instances, but because the time of deployment of that configuration change was so varied. Not all of their proxy servers got that configuration change at the same time, and that would then explain why there was traffic coming and traffic disappearing, traffic coming and traffic disappearing. And these patterns, actually, looking at that, are rather common. Again, I spent a lot of time at AWS. I was looking at pipelines and looking at dashboards. Oh my God, the dashboards every service out there needs a dashboard, and every dashboard has a dashboard, and there's so many dashboards. Anyway, you look at those dashboards, you see graphics like this. What you want to see is the straight line of like everything working as expected and the volume not changing. And once you see these steep spikes, that's not a good pattern to look at, but it is rather common because, again, not everything is deployed at the same time. So this is kind of the nature of these services, that deployments take time to really manifest in the fleet. And only when deployment has finished and every instance in the fleet has gotten the update, then you would see a consistent line or like a consistent problem showing up in those dashboards. And to close out this chapter, a note on operational excellence. That was something our principal engineers were really excited about, the whole word of operational excellence. I've talked about operations quite a lot today. Like, you deploy the product, and then what? Somebody needs to make sure that the thing keeps running. And that, unfortunately, it's not just a step in the program. It is part of the design process. What a lot of organizations do wrong is that they think about operations after they ship the product, and that oftentimes makes it difficult to actually operate that product. Because if you haven't thought throughout the design process about how to get the data that helps you observe operations, how to get the input that feeds your dashboards, et cetera, right? Doing that after your stuff is shipped is just really, really hard. And that leads me over to the third chapter. I talked a lot about problems today. Like, right, writing proof of concepts and then thinking about how to design those into a product and building the product, testing the product, shipping the product, observing the product. And I talked about this gap between research, that proof of concept, and the actual implementation out in the wild. And you would think that just like every other problem in this industry, right, we can automate that away with AI. And unfortunately, that's not actually how that's going to work. But also, let me tell you, I'm not a specialist on AI or even just a really good user. But I do observe how other people tend to use AI. And what I see a lot these days is that we have proof of concepts faster. We have vulnerabilities faster. We have exploits faster. We reverse engineer malware faster. We have detection logic faster. But you know what else? Attacks have gotten faster too. Security operations centers are getting faster. The response process is getting faster. Code is deployed faster. Code review needs to get faster too. And all in all, if you take the whole industry and you make every component of it faster, you know what you get? The same gaps we had before. There is a lot of questions around AI usage in the security industry these days, and like, I can tell you I don't have the answers, but neither do most other people, which is why I'm feeling rather good about this space. Last week, I was at a conference in Montreal. It's called Recon. For reasons I still don't understand, I was asked to join a panel about the future of reverse engineering and the age of AI, and I learned a lot about who else has which questions. And the biggest thing we're all worried about is whether we're soon out of a job. Especially if you're a reverse engineer focusing on malware, focusing on vulnerability discovery, a lot has happened there, right, to automate away the things that you used to do on a daily basis. If I go through either Pro, renaming functions by what I think they're doing, and that took me half a day, now Claude can do that within minutes, and that is scary. That brings me to, what can we currently automate? A lot. I don't really have an answer of what all the different tasks are, but what I'm pretty sure about is that the easy tasks are going away, right? Like decrypting the strings in that sample, renaming those functions that simply just call a list of APIs and so on and so forth. So those tasks will probably go away. Does that mean the jobs are disappearing? Probably not. I put a screenshot of this article on the slide to highlight the craziness that is currently in the media about whether AI is going to automate about everything. And I do not actually believe that the job security we all have is under threat. I do, however, think that our jobs are changing, and I do believe that we need to be on top of those changes as we move forward through this industry. And how will that future look like? Well, most of not all of us in the room are experts, right? Most of not all of us in the room have used AI before. You will notice that it makes you faster. But if you've ever tried to replace yourself with an AI, you might have noticed that you can't actually do that. And I say yet. I don't know how AI would change in the future, and very many people don't know that answer necessarily either. But I believe it's highly unlikely that entire job groups are disappearing from the market. However, also, AI is improving. Something that didn't work a year ago now works. And actually, an example I have for this specific problem is, how many of you have ever tried to reverse engineer Delphi? 2 hands, okay. Great example I had there. Delphi is a programming language. It produces awful binaries, and it's been common in the past to see Delphi-written malware, I believe, for the one and only reason because it's difficult to analyze. Delphi ships with its entire runtime compiled into the executable, and it is difficult to recover that runtime functionality, which makes reverse engineering so much harder and takes so much more time. Last year, I thought I'm being funny and asked Claude to look at my Delphi binary in IDA Pro and analyze that for me, and the results were not good. There was nothing useful coming out of that analysis process, which was kind of what I expected at the time, and I was happy, and I closed off that experiment. Fast forward to this year, a couple of weeks ago, I tried the same thing again with the same Delphi binary, and suddenly Claude had answers, and I was shocked. It took quite a long time, but working through that large code base with all of those runtime functions embedded in the binary was not a large problem anymore for Claude. That gets me to the point that AI is improving rapidly. In a big sense, like not measured, right? Like I'd feel better if somebody was out there like running tests every day and showing us what the model is learning, what it's not learning, like what we're getting better at and what we're not getting better at. What output of Claude I can trust and what output of Claude I need to verify. And that's a big issue in reverse engineering, actually, if you analyze malware with Claude, is that Claude will have answers. They might be true, and sometimes they're not. But anyway, what makes those models better? And again, I'm not an AI specialist, but in the past few years, we were able to throw a large amount of compute at those models. We were able to throw a large amount of data at those models. Also, we've gotten better at the quality of that data, because if you ever worked in data science, the quality and curation is probably the biggest challenge you have in training these models. Like getting the right input data and preparing it for your model to ingest, making sure that biases are removed, et cetera, et cetera. So these procedures have improved a lot. But then also, the scaffolding has improved. And now we don't just have one core model doing all the work. We also have longer context windows, a better tool usage, and we're able to plan the agentic steps that these models these days take to get to the solution of our task. That means that the AI is getting better. So essentially, most of the questions I have today are like, let's say I would have an answer to, might not hold up in the future. But how's security changing in the age of AI? The easy tasks are going away. I already mentioned that. Like decrypting strings in a piece of malware is not the challenge anymore. That also means that the challenging tasks that the AI isn't solving yet are more, right? Instead of like trying to XOR decrypt strings in my malware half a day before I get to the actual hard part, all that's left for me as an analyst is the hard parts. And that is something I think is entirely under stressed these days when we talk about AI. It's like, yeah, the easy tasks are going away, and one day the more complex tasks will go, and possibly one day the complex tasks will be solved too. But essentially, now that we can automate some part but not the other part that's left for us humans to work through and to verify and to make sure if you have a model running on it that the model is doing the right job are so much more. So essentially what we're looking at is that our job descriptions are changing. As a reverse engineer, if you're still looking at each and every instruction, trying to figure out the code flow, like doing things that Claude could do for you, you will be left behind. That's where we need to work on the future all together. But then, like, the biggest problem in that space is, as I mentioned initially, is really just AI speeding everything up. It doesn't make the problem go away. It just makes our problems faster. And that causes a lot of stress. At the panel, we were talking about one question specifically, and that was, will skills still matter in the future? And the answer is wholeheartedly yes. The problems are not entirely disappearing. We will still need human skill to work on those issues. But about the easy tasks going away, that is one particular concern of mine. If the easy tasks are going away, then how will the people learn who aren't yet experts? At the beginning of my career, I was working in antivirus, and I knew nothing about viruses or antivirus or reverse engineering. What I learned a lot about in the days, though, was to clean up the signature database, how to extract byte patterns from binaries, how to look at the easy functions in an executable, and so on and so forth. So those easy tasks that I was doing at the time taught me a lot about how to do my job in the future. And now, 15 years later, I don't do those easy tasks anymore, right? They're easy. I focus on the more complex parts. But the easy tasks are what taught me how to do my job. And that gets me to the topic that will be closing this keynote, AI and the security community. For the last 11 years, I've been running a hacker bootcamp for women. It's called Black Hoodie. It is intended to pull young engineers into the direction of security research, and we've been rather successful. Now I'm looking at this whole security community building process, and I'm concerned because, as mentioned, the easy tasks are going away. And a lot of people come in not knowing much about the task at hand itself, and they're supposed to start at a level where our generation had already had years and years to learn the profession. The security community itself, though, and that gets me back to Troopers, the community itself will be changing, right? If our job descriptions change and the topics we talk about at conferences, they change as well. And what has me concerned with AI specifically is that everything goes faster, as mentioned. Then we all learn faster. We all have more dopamine because, of course, we have more success. We write more exploits. We analyze more malware. And that eventually leads to stressors. And you have no idea how many people in recent months I have talked to who all think about starting farms. It is concerning. There's a lot of us senior engineers who are at the brink of burnout, who want to go quit their jobs and move to the woods. I myself have bought a camper van to do exactly that. And I don't really have a good solution for that other than self-management. Like the stress we're all under these days is vast. Then there's another point on the slide where it says, are we evening out the playing field or leaving most of the people in the dust? And there's no good answer to that question either. AI certainly has leveled out some playing fields where learning subjects that otherwise would have been hard to learn are now more tangible. Last week, I had a conversation with a researcher, his name is Dragas Rubio. He has a 9-year-old son who recently, with the help of Claude, wrote a piece of software that can turn Word documents into different representation that can help him read the documents on his reader. I don't know what device that was exactly, a children's device for reading purposes, and that didn't do Word documents. And now he can read Word documents on there because he figured it out with the help of Claude. And that had me mind blown. Like, if 9-year-olds can write document converters, then what will they be able to do when they're 22, right? Finally, community building. I'm a big fan of community building. I'm a big fan of the juniors and a big fan of the people who are just getting started. And that has been harder than it has ever before. Black Hoodie is a series of workshops where we hold like 1 to 2 day long trainings, and we want to bring challenging tasks to those students and show them what the industry is really about. That doesn't really teach them a whole skill, right? If you try to teach someone reverse engineering for a day, they will be able to open the binary in ILA Pro, and they will be able to look at the code, and that isn't yet reverse engineering the malware. But it is a start. However, the bigger goal that Black Hoodie had right from the get-go was building community. To get those young people interested in this field, show them it's approachable, show them it's learnable, make them part of a community which could show them the way in the future, provide mentorships, provide tickets to conferences, provide insights, reviews on project they were doing, help with CVs and resumes, help with jobs, etc. So that's the whole goal of that community. And what that told me was that this community is a job for everybody. The veterans and the juniors, it's all one ecosystem. Even if you're a senior engineer in this field, you will not get very far without the juniors by your side. And that is why we need to take care of our community. And how can we sustain our community? One big point that's more important than ever before is to create opportunities. Because AI is the component that's taking away the opportunities. The easy jobs, right? The low-hanging fruits are going away. I don't know how that situation currently is in Germany, but in the United States, a lot of the bigger companies have been in hiring freezes for multiple years now. Like Amazon specifically hasn't had junior roles open for hiring to the public since 2023, which is a lot of juniors not getting jobs, and that is concerning. And that's what I mean with the opportunities. If these opportunities go away as a community, we need to look into how to create more opportunities for the people who come after. And that gets me to the bottom line. I believe I'm at the end of my slot, yes. Research, again, is curiosity-driven. I talked about that in the beginning. It produces possibilities. Production is constraint-driven. It produces reliability. The AI component that we're now all adding to that process makes everything faster. It doesn't make the core problems go away necessarily. And what that means for us as a community is not necessarily whether AI will replace us, but whether we can still grow the next senior engineers in that fast enough. And that was my keynote. Thank you very much for your attention, and I'll see you all. Thank you. I'll see you all at the run tomorrow morning at 7:30. Thank you.